Every time you drive, run, or order food, you use it. But have you ever stopped to wonder how your phone knows exactly where you are anywhere on Earth? It feels like magic, but it's actually an incredible feat of science and engineering. Let's uncover the invisible system that guides our modern world. Welcome back to Understanding the World. Today, we're diving into the Global Positioning System, or GPS. We'll explore how this network of satellites orbiting high above us communicates with the tiny chip in your phone to pinpoint your location with amazing accuracy. So, what exactly is GPS? It's a satellite-based navigation system owned by the United States government and operated by the U.S. Space Force. Originally developed for military use, it was made available for civilian use in the 1980s. The system consists of three main parts: the space segment, the control segment, and the user segment. The space segment is a constellation of about 31 active satellites orbiting the Earth twice a day. The control segment is a global network of ground stations that track the satellites, monitor their health, and upload corrected data. And finally, the user segment is more specifically, your GPS receiver, like the one in your smartphone. Now for the really cool part. How does GPS find you? It all comes down to a simple but brilliant concept called trilateration. Imagine you're lost and you ask 3 different people how far you are from their town. One says you're 10 miles from town, another says you're 15 miles from town B, and a third says you're 20 miles from town C. If you draw a circle around each town with the given radius, the single point where all 3 circles intersect is your exact location. GPS works similarly, but in 3 dimensions. Each satellite in the constellation continuously broadcasts a signal containing its precise location and the exact time the signal was sent. Your GPS receiver picks up these signals from multiple satellites. By measuring how long it took for each signal to arrive, it can calculate its distance from each satellite. With signals from at least 4 satellites, your receiver can pinpoint your latitude, longitude, altitude, and the current time with incredible precision. The 4th satellite is crucial for synchronizing your receiver's clock with the super accurate atomic clocks on the satellites, correcting for any timing errors. But how accurate is it? Really, a typical civilian GPS receiver is accurate to within a few meters. However, several factors can affect this accuracy. The Earth's atmosphere, specifically the ionosphere and troposphere, can slow down the satellite signals, creating slight delays. This is known as atmospheric distortion. Additionally, signals can bounce off large objects like buildings or mountains before reaching your receiver, a phenomenon called multipath error. To combat these issues, the GPS control segment constantly monitors atmospheric conditions and sends corrections to the satellites. Advanced techniques like differential GPS DGPS use ground-based reference stations to provide even more precise corrections, achieving accuracy down to the centimeter level. While we mostly think of GPS for navigation, its applications are incredibly diverse. Farmers use precision GPS for automated tractors and targeted crop spraying, which increases efficiency and reduces waste. Scientists use it to monitor tectonic plate movements and predict earthquakes. It's essential for synchronizing financial transactions and telecommunication networks across the globe. Even emergency services rely on GPS to locate people in distress and dispatch help quickly. It's a technology that has silently revolutionized countless industries. And it's not just the US-owned GPS. Other countries have developed their own global navigation satellite systems, or GNSS. Russia has GLONASS, the European Union has Galileo, and China has its BeiDou system. Modern smartphones and devices are often equipped with receivers that can use signals from multiple systems simultaneously. This multi-GNSS capability means your device can see more satellites at any given time, resulting in faster and more reliable positioning, especially in challenging environments like dense urban canyons. So the next time you open a map app or track a package, take a moment to appreciate the complex dance of dozens of satellites ground stations, and intricate calculations working together just to guide you home. What's the most surprising thing you learned about GPS? Let us know in the comments below. If you enjoyed this explanation, please give this video a thumbs up and subscribe to Understanding the World for more science stories explained simply. Thanks for watching, and we'll see you next time.